All right, look at you guys, right? All right, so this mass is going around in a circle like that, and it's holding, as it goes around a circle, this is at a 30-degree angle. So here it says draw and label arrows to represent the forces on the ball in the position shown. So what you want to do is you want to draw arrows that emanate from the ball, right? Kind of like this. Okay, only maybe not in that direction, right? Draw arrows that have their tail on that ball, and I'm going to give you a clue. There's two different forces, okay? One of them is the tension in this string, and the other is the weight, okay? Label those forces, right? So you can label them using the words I just said, okay? And then state and explain whether the ball is in equilibrium. What that means is that if we add up all the forces, they add to zero, right? This means the sum of all the forces add to zero. Another way to know if it's in equilibrium is that it's not accelerating, that the acceleration is zero. Now I'll give you a clue, okay? This thing is moving and it's not going in a straight line at a constant velocity. It's going in a circle. So you have to decide, I'm not going to tell you, but you got to decide, does that mean it's accelerating? Okay, and therefore, if it's accelerating, the forces have to add not to zero. You can also look at the forces that you drew, and you have to ask yourself, did those forces possibly add to zero, right? So there's lots of ways to go at that, okay? But that's what they're going for, right? Do the forces on this ball add up to zero, okay? Now, on the second part here, they're asking you to actually determine the speed of rotation of the ball, okay? And so basically you've got this force, the tension of it going up there at an angle, and I'm not very good at drawing 30-degree angles, right? But that's a 30-degree angle, and that's got a component that's horizontal, right, and a component that's vertical, okay? This vertical component has to equal the weight of the ball, so that's going to be 0.25 times 9.81. Okay, so we know this side of the triangle, we know this is a 30-degree triangle, okay? So you're going to use your trigonometry, okay, to figure out what this side of the triangle is, yeah? Okay, so again, the upward component of that tension has to equal the force of gravity. There's no other thing that could hold it up, right? And this is the mass, right? There's the acceleration of gravity, right? So it's going to be m, right? Once you figure out what this force is, then I'll call this, I don't know, force, the centripetal force, right? The centripetal force also equals mv squared over r. Now, there probably is a way to do this without even using the m, right? Okay, because I'm noticing that we're using it to find this, and then we're going to divide by it here, okay? But once you find the length of this side using your cleverness, I don't know, maybe tangent or something like that, right? Okay, you're going to use that force, and then you know the mass, you know the radius. They tell you the radius is 0.33, right? And you can find v. Yeah, I know you can do it. You're smart.